Hello everyone and welcome to my YouTube channel. Okay, so in this video we will determine limit if the limit exists. So the question given is limit x approaches to 3 to x squared. So the properties of limit is that limit does not apply on the constant. So here 2 is a constant. We can take this out and write down the limit now. Now one more property is that if the limit is not in fraction form, a over b form, and it's not giving you infinity, then you can straight away put the limits in it. So we put the limit straight away, and that gives you 3 threes are 9 and this in 18, right? Similarly, you have another problem where x approaches to -4, 5x plus 15. According to the limits property, you can split the limit into this term and into this term. So limit x approaches to -4, 5x plus, now this is a constant, so I told you the limit doesn't apply on the constant, so you can write down the constant as a separate without the limit. Now again, this is a constant multiplying to the x, so we can take it out. And then you can apply the limit on the x, so that is -4. And that's -4 times 20 times 5 is -20, and -20 plus 15 gives you -5. Now another problem is find out the limit of this piecewise function. And it is less than, when x is less than 5, you have 2x, and when x is either equals to 5 or greater than 5, then you use this function. To find this out limit is that we can split this into two parts, to 5 from negative side and the limit x approaches to 5 from the positive side of this given function. So if we want to find out the limit when we are approaching 5 from the negative side, so you can see that x is less than 5 means the negative side of the x-axis of the x. So we can write the limit x approaches to 5 from negative side. The function that we have to use, either this or this. We can see that when you approach to x, 5 from negative side is this one. So you have to use 2x function. Again, 2 is a constant, we take it out, and x, now apply the limit, and then you get 10. Similarly, on this one, you can apply the right hand side limit. When x is 5 or greater than 5, you have this function, so you can apply the limit on 20 minus 2x. 20 is a constant, so we don't apply limit on that, and then you apply limit on the second one, 2x. Again, 2 is a constant, so you can take this out. Now again, just apply the limit, -2 times 5, 20 minus 10, you have 10. So we can see that the limit, the right hand limit and the left hand limit are both 10, so you can say that the limit x approaches to 5 of 2x and 20 minus 2x when x is less than 5, and when x is greater than 5 is equals to 10. Now this one is exactly the same, so you have to write down the left hand limit and the right hand limit of this function. So 5 approaching to 5 from negative side, the function that we are using is this one, 2x squared, and then the limit of x approaches to 5 from the positive side. So that is this one, which is 2 minus x. 2 is a constant, so we take it out. And then apply the limit. So 5 squared is 25. 25 times 2 is 50. Now the right hand limit, 2 is a constant, so we don't apply limit on the 2. The only limit that we apply on is on the x. Now straight away put the limit on, apply the limit, and then you can see that this is minus 3. Since the left hand limit is not equals to the right hand limit, so limit x approaches to 5 of this function for x is less than 5 and greater than equal to 5 do not exist. Yet another question, or with a similar procedure, we have to find out the limit from the left side. So this is the left side limit, 5 minus 2x, and then the limit, from the right side, which here is 2x. So we cannot apply limit on the constant. We can apply the limit straight away. I'll take the 2 out, and then we can apply the limit on the x, which is minus 1. So 5 minus minus plus 2, and that is 7. If we talk about this one, we take the 2 out, apply the limit. You can see that is minus 2. So you can see that the left hand limit is not equals to the right hand limit. So limit do not exist. One last problem of the similar type. So limit h approaches to 0 from the positive side. From the negative side, we have this one, which is x squared, and the limit x approaches to 0 from the positive side, we have 0.5 x squared. Now if we apply the limit, 0 squared is 0, and similarly if we apply the limit, 0.5 times 0 squared is again 0. So you can see that the left hand side and the right hand side, both limit are same and they're equal. Then 0.5 x squared for x less than 0 and greater than 0, the limit is 0. So if you have a function with which you have to find out the limit, and the function is of this type, then you have to look at it. If you put x is 8 here, this gives us 0, and if you put it here, this gives us 0 by 0 form. So if this is the form, it means some simplification can be done. You have to do something that you cancel the 0 from the bottom. So for that, you have to do is simplify the problem. You know that x squared, you can write the above as x squared minus 8 squared, and then according to the formula, a squared minus b squared is equals to a plus b and a minus b. So we can write this as x minus 8 and x plus 8 divided by x minus 8. So this x minus 8 will cancel this x minus 8, and then you can apply the limit on the x plus 8, which again we do not apply limit on the constant. So if you apply the limit on the x only, that would be x 8 plus 8, and that is 16. Again, if we put minus 2 minus 1 here, that gives us 3, and that is plus 9, so that gives us 0, and the down one is minus 3, and plus 3 gives us 0. So if this is the form, it means there is further simplification that we can do. So let's start it and see what simplification is needed, or one simplification are needed. So if you take common 3 from this one, this is left of this form, and if you take 3 common from this one, we are left with this one. Now this is the quadratic equation. You can factorize it with whatever method you know or you have studied. So x squared minus 3x minus 4, x squared, you can do that with x squared. We need minus 4, so I can do is minus 4x plus x minus 4. This is the first and last rule, or you can call this splitting the midterm, or they call it midterm break. So I can take common x from here, so x minus 4, and if I take 1 from here, this is x minus 4. We have x minus 4 common, so here is left x and here is left 1. So you can write this down now. Limit x approaches to minus 1, 3 times x minus 4 x plus 1 divided by 3 times x plus 1. We could cancel 3 from here, and you can cancel this one. So the only limit that we have to apply is on x minus 4. So that is minus 1 minus 4 gives us minus 5. And now let's do this final exercise question. Again, if we put 3 over here, this is becomes 0, and that gives us 9, 18, and that gives us minus 21, minus 15. So we can, in short, we can simplify this. So if you want to do this, we want to factorize this with the first or midterm break, so you can say that would be minus 30x squared. And how do we get minus 30 would be 10 times 3. So you can split that 2x squared minus plus 10x minus 3x and minus 15. You can take out 2x common, so x is left, and here 5 is left. And if I take minus 3 common, x is left, and plus 5 is left. X plus 5 is common in both, so minus 3. So you can factorize it, and you can write this down by x plus 5 into, 2x plus 5, and x plus 5 and 2x minus 3, if I am not wrong. So x plus 5 and 2x minus 3, it means they're not cancelling each other. It means if you put 3, this would give you the limit do not exist. And let's check whether the above, whether this is this form or not. So if we put 3 in here, 2 times 9 plus 7 times 3 minus 15, obviously this is not going to be 0. So it's not 0 by 0 form. So the simplification was not needed. So you can straight away, if this is not 0 by 0 form, you can straight away say that the limit do not exist. But if it's 0 by 0 form, you have to factorize it and do the cancellation, which in this case is not possible. Okay, in this section we will solve questions that says that find the indicated limit. So we are given a question that limit x approaches to 0, 3x squared minus 5x plus 7. To find out the limit, first we have to understand a few rules. First rule is that if x is approaches to some number and you're taking the limit of a constant number, so the limit does not apply and you get this exact same constant. The next rule is if you have x to the power something and the x is approaches to a, then just replace the x with that x approaches to a value. So that becomes x power n or x power anything, whatever is given. Similarly, if x power something is multiplied by a constant, then what you can do is take out the constant and apply the limit on the x term, and you already know the value, how to find out the limit of x term. So that would be c a to the power n. So here we will apply those rules of limit. X approaches to 0. First we will apply on the first term. One more rule that we can use is that if limit is applied on different functions, if they are added, what you can do is you can apply the limit separately on both of them. If there is addition, there is subtraction, you can use for both of them. So if there is subtraction, you will just put subtraction over there. So here you have three different functions, and there is plus and minus and plus between them. So I can apply the limit to this one, then minus, apply the limit to the second one, and plus apply the limit to the third one. Now we can see that this one is resembling this property, so we will take out the 3. We will take the 3 out from the limit and apply the limit to x square only. Here 5, we will take out 5 and apply the limit on the x. And since this is a constant, so we said that if you apply a limit to a constant, it gives you the same constant, which means limit doesn't apply to the constant because there is no x in there. Now by the property of this, or this rule limit, just apply the limiting value for x. So we wrote 3 and apply the limit 0 value for x, and minus 5 the value of x, and plus 3. 0 times anything, 0 times anything, and if you add them up, this gives you 3. Now in the second question, you are given that the limit x approaches to 2 of 2x cubed minus 10x. So again, applying the rules of separation, you apply the limit on this term, which is here, and this term, which is here, right? Again, the rule says that a constant, you have to take out the constant, take the constant out of the limit. So we took the 2 out and apply the limit on the x cube only. Here we take out 10 and apply the limit on the x. And again, to the limiting rule, just put the value of 2, whatever is here, in for x, and in here for the x, taking the cube of x. 2 is 8, and 10 times 2 is 20, so that gives you 16 minus 20 over 16 minus 20, which gives you minus 4. In question number 3, again we have two functions, and there is subtraction between them, so you can separate them, and we can write this as 1 over 3 x power 3 and minus limit x approaches to 2 7x squared. Again, 1 over 3 is a constant, so we will take this out of the limiting value. Here 7 should be out of the limiting value. Now apply the limit, so which means 2x cubed minus 7, apply the limit, square of 2, that is 8 by 3 minus 7, that is 4. So we can say that 8 or 3 over 28. If you want to further solve it, you can take the LCM, minus 28 into 3 divided by 3. and that shall give you 8 minus so that should give you minus 76 over 3. Now question number 24 is about a function, a rational function, where you can write it in this form. If you have something, so if you have a function of this type, then you can apply the limit on the numerator, above one, and denominator, the below one, separately. But there is a condition that the denominator ones, if you apply the limit, it should not be 0. So if you look at this one, now if you apply the limit x approaches to 3 over here, this does not become 0, so we can apply the limit separately on 2 minus 8 and the limit x approaches to 3 on x plus 4. So now you don't have to write down all the time the separate limits. You can say something straightforward. So for instance, I will apply the limit straight away and take out the 2 from the limiting value. And since minus 8 is a constant, so I will just write down the constant because the limit and constant value is a constant. Similarly, here I will apply the limit on x to 3 on the x, and 4 is a constant value, so the limit of this would come as 4. Now you have to apply the limit, so applying the limit gives you, and that gives you 6 minus 8, and 3 plus 4 gives you 7, so that gives you minus 2 over 7. Now this is a different question. So again, in this one, we can see if you apply 2 over here, this is 2 square is 4, 2 times 4 is 8, so it doesn't give you 0, so you can apply the limit on the numerator, which is 2x squared plus 3, and the denominator, which is x squared plus 4x minus 2. Again, I'm using a little shortcuts, and 3, since it's a constant, so the limit applies and gives you the same constant. Now x approaches to 2 on the x square, plus since 4 is a constant, we take out the constant, and minus 2 is a constant, so it gives you the same constant. Now if you apply the limit, the square of 2 times the square of 2 plus 3, the square of 2 plus 4 times 2 minus 2, you simplify this, 2 times 4 plus 3, and that gives you a 4 and 8 and minus 2. And then you multiply them, 8 plus 3, 12 minus 2 is 10, so that is 11 by 10. Now this one, the limit x approaches to minus 4 of 250. 250 is a constant, so what would be the answer? Would be the exact same value, 250. Now this one is x approaches to 0 of 175. Again, 175 is a constant, so when you apply the limit, it will give you the same exact value, 175. Now in this one again, we have a function above and a function below. The below one will not give you 0, so we apply the limit on the above and separately apply the limit on the below. Now you can see that you can straight away apply the limit x approaches to minus 10 on the x square, and if you apply the limit on 25, since 25 is a constant, so it will give you 25, And then you can apply straight away the limit on this one would be minus 10. Here if you apply the limit, that is minus 10 square plus 25 divided by minus 10, and this gives you 100 plus 25 divided by minus 10. Minus minus becomes plus, right? So that gives you 125 divided by 10 over the minus, so you can write this as minus 125 over 10. You can further simplify it by multiplying by dividing this by 5 and this by 5. Or you can write this is 12.5. Now if you see this question, if you look at this question, it's exactly the same as from the beginning ones. So limit x approaches to 1, 3x cubed plus 2x squared plus x. Apply the limit separately on all three of them, and then you have constants as a coefficient, so we take them out and apply the limit on the x values, and here we can apply straight away the limit which gives us 1. Now if you apply the limit 1 cube plus 2 times 1 square plus 1, 1 cube is 1 times 3 is 3, 1 square is 1 times 2 is 2, and plus 1, this gives us 6. Now this question is again exactly same like the beginning one. So x approaches to minus 2, and here you can see it's minus, so you can either just put minus over here or you can take it out, so it doesn't make any difference. And 8x squared, so you can apply the limit over here minus 2 power 4, and you can take the 8 out first, and then you can apply the limit in the next step. So the square of 2 minus 2 is giving you minus 2 times minus 2 is plus 4, and then into minus 2 gives us minus 8, and then into minus 2 gives us plus 16. So plus 16 into minus. So this give us plus 16, and 8 times, if we put minus 2 square, so that gives us minus 16 plus 8 times this gives us 4. So minus 16 plus 32 gives us plus 16. This one again, apply the limit separately on each term, or you can say on each function. I'll take out straight away the 5, and since it's a constant, so it will give us constant. I don't want to apply the limit here because you know the rules now. So minus, apply the limit 5 minus, apply the limit. So 2 times 2 is giving you plus 4, and then into minus 2 gives us minus 8. So minus, this gives us minus 8. 5, this gives us 4, and plus 10. So minus into minus becomes plus 8, and that gives us 20 plus 10. So that gives us 38. In this one again, I'll take out 5 and apply the limit, and the 10 is a constant, so we take it out. Now straight away apply the limit. 2 cube 10 into 2 square, 2 cube is 8 and square is 4, so that gives us 40, and that gives us 40. So the answer is 80. Okay, so section 15.2 continues. The next question is question number 13, which says that limit x approaches to 5, 4x minus 20 divided by 3x squared minus 7x plus 5. So we have to find out the indicated limit. We can see that the down one, if you put 5, is not 0, the denominator. So we can separately apply the limit on the numerator and on the denominator. Now again, we know the rules. 4 is a constant which is multiplying to x, so we take out the 4 and apply the limit on the x. And minus 20, since it's a constant, so I do not want to apply the limit on it, and just write it down by the property of the limit is 20. Similarly, you can apply on the denominator ones, so that is 3x square. We take out 3 and apply the limit on the x square. From minus 7x, we take out 7 and apply the limit on x. And since 5 is a constant, so we just write down the constant, because the limit of a constant number is the exact same constant, right? Now you apply the limit, so 4 times x, which is 5, minus 20, and then you apply for x5 and for x5 over here, and then you multiply. That gives you 20 minus 20, and that gives you 75. 25, 5 square is 25 times 3 is 75, and 7 times 5 is 35, and 5. That gives you 0, plus 20 minus 20 gives you 0. 0 by anything becomes 0. Question number 14 says that the limit x approaches to minus 2 of this function is again in the numerator and denominator form, p over q form. So we can apply the limit on the above and on the below numerator or denominator and denominator. So now since 10 is a constant, so we will write down 10 as it is, because the limiting value would be 10. Then minus, and then you apply the limit on the x square separately. Now the next thing is this one. So 5 is a constant, we take it out. And then minus, this is 8x. So from the rules, the constant comes out of the limiting value, and apply the limit on the variable x. Similarly, from 2x square, we take out 2 and apply the limit on the x square. Now simply apply the values. 10 minus, instead of x, we will write minus 2 whole square, and then 5 minus 8 times, instead of x, minus 2 plus 2, and x square is minus x. So if you calculate, this gives you 10 minus 4, and 5 plus 16 plus 8, and that gives you 6 over 29. Question number 15. It is using a different property now. Two functions are multiplying. So the property, if you have one function and two functions and they're multiplying, and you apply the limit on it, you can apply the limit on both of them separately, and still they will multiply. So what we can do is we have one this function and one this function. So we'll apply the limit on both of them separately and multiply them. So we apply the limit on this function into apply the limit on this function. Now again, using the old property, 6 comes in front, or you take it out and apply the limit on x cubed. 2 comes in front, you apply the limit on the x, and then multiplication, then 5 comes in front and you apply the limit on x, and minus 10 is a constant, so the limit of a constant is the same constant. So we write that as it is. Now 6 as it is, and then you apply the limiting value minus 3 for x, so we have minus 3 power 3 plus 2 as it is. Instead of x, we write minus 3. 5 as it is. Instead of x, we write minus 3, and this is as it is. Minus 3 times minus 3 in 3 times gives you minus 27. You multiply into 6 gives you 162. And 2 times minus 3 gives you minus 6. 5 times minus 3 gives you minus 15. Minus 10 as it is. If you add them up, that gives you minus 25. This gives you minus 68 and minus 25. If you multiply them, you get 4,200. Okay, question number 16 is a little bit complicated. So you have two functions. One is this one and the other is this one, and they're multiplying. So first we will apply the property of multiplying. You apply the limit on this function into the limit on this function. Now this is again the numerator and denominator, or above or below function. So if you put 5 over here, the below is not 0, so we can apply the limit above and below. So you can apply the limit above on this function and below on this one, and you can straight away apply the limit on this one on x square, and minus 12 is a constant, so if you apply the limit, it gives you minus 12 anyway. Now this one is, if I apply the limit on the x, you can write them separately. I'm just doing it in shortcuts now because you already know how to solve them. So you apply the limit 5 in place of x. 5 and 3 as it is, and in this one 5 and 6 as it is. And if you apply limit 5 over here, the square of 5 is 25 and minus 12. So that gives you 8 over 11, and 25 minus 12 gives you 13. If you multiply them, it gives you 104 divided by 11. In question number 17, again you can apply the limit above on the above function and on the below function separately. 2x plus 7. Now I will not write them separately, I'm just straight away applying the limit. So minus 4 square, 8 times minus 4, and minus 14 will come as it is. And if I apply limit here, that will be minus 4 and 7 as it is. So that is 16, that is minus 32 and minus 14, and that gives us minus 8 plus 7. So if you calculate them, minus 6, 36, minus 36 plus 16 gives you minus 20 or minus 1, so that gives you 20. Oh, sorry, that is 46. 46 minus 16 gives you minus 30, so that is plus 30. Now question number 18 is again, we apply the limit on above or on the numerator and apply the limit on the denominator. Now again I will just straight away apply the limit. So instead of x we will write x square, we will write 1 square, plus 3 instead of x we will write 1, and minus 24 as it is. For x we will write down 1 and minus 3 as it is. So that gives us 1 plus 3 minus 24 divided by minus 2. So 4 minus 24 gives you minus 20 divided by minus 2, minus minus cancel. That gives us value of 10. Okay, in these problems now, if you see that if you put x is equals to minus 4 over here, so minus 4 plus 4 gives you 0. It means that the limit x approaches to minus 4, x plus 4 is 0. So if you have denominator 0, you cannot apply limit above and below. So once you have this thing, you have to check whether this this function can be further simplified or not. And for that one other reason is if you apply the limit and above and below both are 0, it means you can simplify this further. So if you can look at this one, we can simplify this one is x whole square and minus 4 whole square, x plus 4. And we know a formula which is called a square minus b square can be written as a plus b and a minus b. So you can compare this one with this one. You have a is x and b is 4. So we can write this down by x plus 4, a plus b, and x minus 4. Now we can see that this will cancel with this one. So you are left with only x approaches to minus 4, x minus 4, which is a very simple one. So you apply the limit on this one. So we apply the limit x is equals to minus 4 on the x one. And since 4 is a constant, so it will give us the value 4. Now if I apply the limit for x, we write down minus x minus 4, and that is minus 4 minus 4 gives you minus 8. Now this one is again a similar question. If I put minus 9 over here, this gives me 0. And if I put minus 9 over here, this gives me 81, minus 81, 0. So if this is the form, it means it can be further simplified. So we can simplify this as, we can write this as a square of 9 and a square of x and 9 plus x. Again, according to the formula, this would be 9 plus x and 9 minus x and 9 plus x in the denominator. So this will cancel this one. And then we apply the limit only on 9 minus x. Now 9 is a constant, so it stays as it is. And if you apply the limit on the x only, so 9 minus, and instead of writing x, we will write down its value, limiting value. So that gives us 9 plus 9, and 9 plus 9 is 18. Now in this one you can see that the limiting value x is approaches to c, some constant. So simply you can apply the limit x approaches to c on the x cube. The constant terms, you can take them out and you don't need to apply the limit on the constant. So you have 4 c cubed minus 5 c squared plus 10. So you can write this as 4 c cubed minus 5 c squared plus 10. And that's the answer. Now this is the last question of these type of questions. So again, you apply the limit on each of the parts separately. Limit x approaches to minus d. Again, x approaches to minus d of x. And 3 is a constant, so we don't apply the limit on that, or you just get the same value. So that's why we don't apply the limit on it. Minus 2 times minus d and plus 3. So the d minus d square is d square, and minus minus gives you a plus, so plus 2d and plus 3, and that is the answer. Okay, in this video we will discuss horizontal and vertical asymptotes and find the limits of a given function. So what is a horizontal asymptote? A line y is equals to a is called a horizontal asymptote if and only if the limit x approaches to infinity, f of x gives you that number a, or if the x approaches to minus infinity of the function, it gives you a. And similarly, a vertical asymptote is a line x is equals to a of the function f if and only if you approaches a from negative side, it gives you positive infinity or negative infinity, or if you go to a from the positive side, this gives you positive infinity or negative infinity. So let's apply this to different problems and find out. So if we have to calculate the limit of this number or this function, then we can see that infinity, if we replace infinity, that would give us 4 over infinity square, and anything divided by infinity is equals to 0. So if we substitute infinity over here, this is infinity square, and this gives us 0. Or you can find this out from the table. If you put the values from a very large value and goes towards 0, and then from 0 to positive infinity, then you will see that this term is becoming smaller and smaller and smaller, and at the end it approaches to 0. Or you can straight away put the value, because you cannot simplify it further. So if you substitute the value, it will give us the 0 value. Now for the horizontal asymptotes, what we say that if the limiting value of x approaches to infinity, f of x in this case is this one, is equals to some number, and that number here is a, and here that number we got is 0. This implies that your horizontal asymptote is y is equals to a. In this case, a is equals to 0. So this is our horizontal asymptote. For vertical asymptote, we said that the limit x approaches to, here the a is 0, so to 0 from negative side, and the function is this one. So this gives us, either we go from negative side or from the positive side, it gives us 0. You can check the negative side, the positive side also if you want. From the positive side, this will also gives us 0. So this implies the vertical asymptote is x is equals to 0. So the limit is 0, horizontal asymptote is y is equals to 0, and vertical asymptote is x is equals to 0. When we're dealing with problems where x approaches to infinity or minus infinity, and you have a function of this type, then what you have to do is you have to look at the numerator and denominator, and you can simplify this by deleting all the terms except the terms in the numerator which has the highest power of x, and in the denominator the term with the highest power of x. So you can write this down in this format: limit x approaches to minus infinity. So this is 5x minus 3. The highest term power of x here is 5x is the highest term, highest power of x, and we remove the 3, and in this one the highest is x plus 10x, so you have only x here, which is with the highest term. And now we can see that x can cancel x, so the limiting value that we have is x approaches to minus infinity is 5, and if you apply the limit, there is no x, so this would give us the constant value 5. So we can see here our a is 5 according to that rule. So the limiting value is 5. Now the first thing was horizontal asymptote. The horizontal asymptote, we said that the limiting when x approaches to positive or minus infinity, 5x minus 3, x plus 10 we found was what? Was 5. This implies our horizontal asymptote y is equals to 5. Similarly, for the vertical asymptotes, we say that the limit x approaches to 5 from negative side, 5x minus 3 and x plus 10. Again, we can, if we apply the value straight away over here, this gives us in the above 5 minus 3, and in the below 5 plus 10. So that gives us 25 excuse me, 25 minus 3 gives us 22, and that gives us 15. So we can see that this is not giving us infinity. So to find out the vertical asymptote, this function where limit x approaches to a from negative side, 5x minus 3 over x plus 10 is equals to, it has to be either positive infinity or negative infinity. How this can be positive or negative infinity is if this portion is 0. So if we substitute x plus 10 is equals to 0, this implies x is equals to minus 10. So x is equals to minus 10 is the vertical asymptote. Now in this problem, again, we can use the method of the power, the x with the highest power, and deleting the rest of the terms. So above one is again only a function of x, so we do not need to delete anything, and the below one has plus 100 with it, so we can just leave 5x. The x will cancel with x. You are left with only term minus 3 over 5, which means the answer is minus 3 over 5. So the limit is minus 3 over 5. For the horizontal asymptote, we say that the limiting value is our horizontal asymptote here, that is y is equals to minus 3 over 5. For the vertical asymptote, we say that when x approaches to a from negative side or from the positive side, this one should give you infinity. And when this can be infinity, when the denominator is 0. So that is 100, sorry. So 5x plus 100 is equals to 0, which means 5x is equals to minus 100. And if you divide both sides by 5, this gives us minus 20. So this is our vertical asymptote. Question number 26 is of this form. So again, we only leave the term of x with its highest power. So here is 8x is the highest power and minus 4x, x cancel with x, and 4 times 2, so that gives us the limit x approaches to minus infinity of minus 2, and so this gives us minus 2. The limiting value is that one. Horizontal asymptote is what? Y is equals to whatever is the limiting value. And the vertical asymptote is, we say that when x approaches to a from negative or positive sides of 8x plus 10 divided by minus 4x is equals to infinity. And when is this infinity? When the denominator is 0. So it means x is equals to 0 is the vertical asymptote. This one is, if we apply the rules, if we put the limits in this one, so this gives us minus infinity, right? So no limit. So we don't have a limit for this one. So the horizontal asymptote would be what? We said that y is equals to something over here. It's not a number, so there is no horizontal asymptote. In vertical asymptote, we said that the limit in the denominator, something has to be 0. There is nothing in the denominator here, so no vertical asymptote in this case. In this problem, again we apply the rules of highest power of x. So that term with the highest power of x here is x square. We remove 3, and here is only x. So now we can see that this will cancel, the square will cancel with x. So we are left with x approaches to infinity and x. So again we have infinity, which means no limits for this one. And then we have the horizontal asymptote would be no horizontal asymptote. For the vertical asymptotes, we can see that the limit x approaches to a of the function x squared plus 3 over x minus 4 is infinity. So we have x minus 4 is equals to 0, which means x is equals to 4 is our vertical asymptote. In this problem, again what we have to do is restrict our limit only to the terms of x with the higher power of x. So x cancel with x, this cancel with x, so you are left with 2. So limit x approaches to infinity of minus 2, it means the limit is minus 2, and the horizontal asymptote is y is equals to minus 2. For the vertical asymptote, we said that the limit x approaches to a negative or positive of minus 8x 4x of 1000 is equals to infinity, or when will this be infinity is when this one is 0. So 4x plus 1000 is equals to 0, 4x is equals to minus 1000, and if you divide by 2, that gives us minus 250. So that is the vertical asymptote. This is exactly the same problem. We have 5x plus 10,000 and 2x minus 5,000. So we take the terms 5x, and from here 2x, x cancel out, 5 over 2. When you apply the limit, you get 5 over 2. So our horizontal asymptote is y is equals to 5 over 2. And for the vertical one, we put the denominator equals to 0 and solve this. This gives us the vertical asymptote. In this example, we can see that we have minus 3x cubed is the highest power of x, and here minus x cubed is the highest power, so we leave it here, and minus 3x cubed here. Now x cubed and x cubed will cancel each other, minus 3 over minus 1, this becomes plus 3. So the limit is plus 3, and what horizontal asymptote is y is equals to 3, and vertical asymptote is the denominator, put the denominator equals to 0, and then you solve it. This gives us x is equals to 0 is the vertical asymptote. And this is the final question of this type of problems. So you have 3x cubed minus 500 and 5000 minus x power 3. So in the above one, we took the highest power of x, which is 3x power 3, and in the denominator, the highest power of x is minus x cube. So x cube and x cube cancel each other. This is plus 3 and this is minus 1, so that gives you minus 3. So the limit is minus 3. Horizontal asymptote is y is equals to minus 3, the limiting value. For vertical asymptote, we put the denominator equals to 0. Excuse me. And now solve this one. So this gives us x is equals to the cubic root of 5000. You can calculate that thing. Hello everyone. In section 15.3, the questions from 1 to 14, they're asking you to find the average rate of change, the average rate of change in the function y is equals to f of x when x is changing from x1 is equals to minus 1 to x2 is equals to 2. So the average rate of change is denoted by, or the formula is denoted by, the change in y divided by the change in x. So you can write this as the change in y. So if you write down, you can write this as y2 minus y1 over x2 minus x1. And if we use this function, then if I put x1 here, that will give me a y1, and if I put x2 here, this will give me y2. So y2 would become f of x2 minus y1 would be f of x1 divided by x2 minus x1. So if you are given any type of function, now you can find out the average rate of change in the given function. So the first one is given as y is equals to f of x, and the f of x is given by 3x squared. So what we need is, we are given x1, we are given x2. What we have to find is f of x2 and f of x1. So if we want to find out f of x1 here is minus 1, so we can put, for x1 we can put minus 1, and in the function we just replace x by minus 1. So 3 times minus 1 whole square, and the square of minus gives you 1, so that gives us 3. Now we can find out f of x2, and x2 is given by 2. So in this function we replace x by 2. So 3 times 2 square. 2 square is 4. 4 times 3 is 12. So now we have f of x1, we have f of x2, we have x1, and we have x2. So we can find out the average rate of change of function y with respect to x. So f of x2 is 12 minus f of x1 is 3, x2 is 2, minus x1 is minus 1. So we can say that 12 minus 3 gives us 9, and this is 2 minus becomes plus. So you have 9 over 3, which is 3. So the average rate is 3. Now in question number 5, the function is y is equals to f of x, and that is x squared divided by x plus 4. So if we want to find out f of x1, that would be f of minus 1. Replace x here in this function with the minus 1, so minus 1 square divided by minus 1 plus 4. Square of any number becomes positive, and that gives us 3. So we have 1 over 3 for the f of x1. F of x2 would be replacing x with the 2. So we have a square of 2 and 2 over 4. That becomes 4. The down on 2 plus 4 gives us 6. We can cancel these both by 2. So this gives us 2 over 3. Now we have both the values for f of x1 and f of x2, and we can substitute that in the formula of average rate of change. F of x2 is through 2 over 3, f of x1 is 1 over 3, divided by x2 is again 2 minus 1. So here we have 3, we already know that, minus minus plus, and plus 1 and plus 2 gives us 3. We can take the LCM of this one, so that is 2 minus 1, and here we have 1 over 3 divided by 3, so which means 1 over 9. In question 12, the function is 3x cubed plus 4x minus 5. So what we have to do is again find out f of x1 and f of x2. x1 is minus 1 and x2 is 2. So we replace x by minus 1 in this function. So 3 times minus 1 power 3 plus 4 times minus 1 minus 5. So minus 1 times minus 1 times minus 1 gives us minus 1, and that minus 1 multiplied to 3 gives us minus 3. And minus 1 into plus 4 gives us minus 4 and minus 5 as it is. So if you add all of them, that gives you minus 12. Now we put, for x we replace 2, so that is 3 times 2 cube plus 4 times 2 and minus 5. 2 times 2 times 2 gives us 8, and 8 times 3 is 24, and 4 times 2 gives us 8 and minus 5 as it is. So if you subtract them these things, that gives us 27. Now if we replace all these, substitute all these values in this formula, the average rate of change would be 27 minus 12 divided by 2 minus minus 1. So 27, this minus into minus gives us plus. So 27 plus 12 divided by, and this gives us 3. So 39 divided by 3. So if we divide this by 13, this gives us 13 into 3 gives us 39. The last question is about is the function f of x is equal to x power 4 minus 10. So if you want to find out f of x1, that is replacing x1 by minus 1, its value. In this function we replace x by minus 1. So minus 1 power 4 is plus 1, and minus 10 as it is. If you subtract them, that gives us minus 9. Again, in the same function we put x for 2, or replace 2 by x by 2. So if you replace 2 here, is 2 power 4 minus 10. 2 power 4 is 16, and minus 10 gives us 6. So now substitute these two values and these two values in this formula of average rate of change. So 6 minus 9 divided by 2 minus 1. 6, the minus becomes plus, so 6 plus 9 divided by 3, that is 15 divided by 3, and this gives us 5. So the question number 15 is about, it says that a ball is thrown straight up into the air. It says that a ball is thrown straight up into the air. The height of the ball can be described as a function of time, which is this one. And h shows the height in feet, and t time is in seconds. And they're asking you to find out the average rate of change in the height between when t1 is 0 and t2 is 2. This is part 1. Then second part says t1 is 0 and t2 is 4. And third part is t1 is 0 and t2 is 8. So the first thing that we have to do is find out the formula, which is this one, that the rate of change of average rate of change of height with respect to time is given by h of t2 minus h of t1 divided by t2 minus t1. So what we need to do is to find out this and this, because t2 and t1 is already given. So in this height function, we have to put first t1, which is 0. So for all t we will put 0, so that gives us 0. Now to find out h of t2, for t2 we will put 2. So in this function for t, we will put 2. So minus 16, 2 power 2 plus 128 into 2. So when you calculate this one, this gives us minus 64, and that 128 times 2 gives us 256, and if you subtract them, it gives us 192. So substitute these values in this formula and the values of t1 and t2. So 192 minus 0, 2 minus 0, so that gives us 192 divided by 2, which gives us 96. So the average rate of change in height is 96 feet per second. In the second part, we just replace t1 by 0 and t2 by 4. So if you put t as 4 in here, we get 4 square is 16, 16 times 16 is 256, and 128 into 4 gives us 512. If you subtract them, this gives us 256. Substitute that in the formula. So 256 minus 0, 4 minus 0, and this gives us 64. Now in the third one, what you have to do is you have to just replace this by 8 and calculate the values. This would be 8. So the rest of the calculations you have to find out. So that is 64. You can simply multiply them for 6, 24, 36, 4, 2. So that is minus 10, 24, and 64, 16 plus is 22, and 8 plus 0 is 10. So that gives us a 0. And now we have to put these values in here. So 0 minus 0 divided by 8 gives us 0 feet per second. Right? Now in part B, they're asking you how long does it take for the ball to hit the ground, which means when would be the height 0. So when in this function, if we put height is equals to 0, so we can write this as 0 is equals to minus 16 t square 128 t. Now we can see that here t is common. So here is left minus 16 t plus 128. You can write this as t into minus 16 t plus 128 is equals to 0. Right? They're both the same things. So now this means that either t is 0 or minus 16 t plus 128 is 0. So this means if I leave minus 16 t here and take the 128 to the other side, and if we should divide both sides by minus 16, this minus 16 will cancel that one, and here we have t is equals to, this minus will cancel this, so you have 128 over 16. You can simplify it starting from 2, or if you have a good knowledge of cancellation, you can do it with big numbers. So if you start with a 2, that is 8, that is 6, 64, and 8 are 64. So your t is 8 or your t is 0. So these are the two conditions. When will be the height 0? When will be the height 0? When time is 0 or when time is 8. Time 0 means it hasn't even started. So you cannot take t is equals to 0 because it hasn't even started taking up. So if it's already gone and then it's coming down, then it has to take some time. That's why your answer should be t is equals to 8.